Hello friends, good afternoon. It is Omkar Mahajan from Sweris College of Engineering, Pandharpur. Welcome to the second lecture on properties of line. So we are discussing perpendicular line problems. In last lecture, we have discussed a straightforward perpendicular line problem whereby uh, we studied the basic methodology to solve the simple perpendicular line problem. So now here we will have a next type of perpendicular line problem. Let us read the question statement. So here it is. Complete the projections of line PQ perpendicular to line AB. Point Q is on line AB. True length of PQ is 25 mm. If you do remember, then in previous problem we were asked to find the true length of line PQ, but now here in this problem they have given the true length of line PQ. Now let us look at the given data, what will be printed on answer sheet. So see here in front view we have been given 3 points, A dash, B dash, P dash, and in top view we have been given 2 points, A, B. So we need to start the problem from the position whereby more given data is provided. So here in front view more given data is provided. So we should start our problem from front view onwards. Now how to solve the problem? So we have studied. So let us once again revise it, or let us once again go ahead with. First construct x1 y1 parallel to any one line. So here we have only one line, A dash B dash, hence construct x1 y1 parallel to this line AB. X1 y1. Now transfer the projectors of all these 3 points, point A, point P and point B. These projectors must be perpendicular to x1 y1. See, generally in the solution these projectors must be drawn by faint line, but here in order to get the clarity of video I am making the lines dark, but practically these projector lines must be faint. See now, this is top view, this is front view. After this front view and after this x1 y1 we are getting auxiliary top view. So we need to locate the auxiliary top view, hence take the distances from top view. So we have only 2 points in top view, point A and point B. So take the distance of point A from xy, measure it and mark it from x1 y1 on the projector of A. So here we are getting point A. We'll number it A1. Then similarly measure the distance of point B from xy and plot it on the projector of B from x1 y1. So here we will be getting point B, B1 we will number it. Then join AB, A1, B1. So here we have projector of P, but we cannot locate point P here in auxiliary top view because we don't have point P in top view. So now the next step is constructing x2 y2. So how to construct x2 y2? X2 y2 must be perpendicular to true length line. So here in this view A1 B1 is showing the true length, because here in the previous view A dash B dash is being parallel to x1 y1, hence here it is A1 B1 is true length. So x2 y2 must be perpendicular to this true length line. So extend this true length line as a projector line, so it should be faint. So as we discussed, projector lines must be faint, but here in order to get clarity I am making these lines a bit dark. Then construct x2 y2 perpendicular to this. X2 y2. So now this is auxiliary top view. After this auxiliary top view, here we are getting auxiliary front view. So as we are going to locate front view, we need to take the distances or measure the distances from front view. So here it is the front view. So in this view, we are going to transfer the distances from this view. So now we have here x2, y2. So measure the distances from previous xy. So previous xy is x1, y1. So measure this distance and plot here. Let's take the distance of A from x1, y1. So A's distance and B's distance is same because line AB is parallel to x1, y1, and mark here from this x2, y2 here. So here you will be getting line AB's point view. So we will number it A2, B2 dash 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 because it is front view. Okay, so as it is front view, so we are giving here dash A2 dash B2 dash. Now see here, as we can take the distance of B, we can take the distance of A. Similarly, we can take the distance of P also. This much is the distance of P from x1, y1. But here we don't have the projector of P to mark the distance. So what we will do, for time being purpose, we will mark the distance of P on the projector of AB itself. And we will construct a generator or a generator passing through or locus passing through this point. So this is locus of P. So this is the locus of P. This line is locus of P. So how much it is? So this distance is equal to this distance. Clear? So we have measured from x1, y1, we plotted from x2, y2. So now see here, they have given the true length of line PQ as a 25 mm. So we have seen in previous problem, after x2 in perpendicular line problems, after x2, y2, we get true length of second line. So here true second line is PQ. So here we should get true length of line PQ after x2, y2. So true length of line PQ given is 25 mm. So measure 25 mm in compass. Keep compass point on AB and mark two arcs, one on this side, one on this side. So see, the Q point can be here, P point can be here, or the P point can be here. Anywhere you can locate it. So in order to get it outside, so we will locate or we will assume point P to be here. So as point P is here, ultimately point Q becomes here. It is Q2 dash. So why Q is here? Because in the problem it is given point Q, see here, point Q is on line AB. So that is why it is AB's point view, hence Q is on AB. So we are getting ABQ here. And this is point P2 dash. So join. So this is line PQ having true length 25 mm. Done with. So now we need to take the point P back. So how to transfer it back? Perpendicular to x2, y2. Point P should be transferred perpendicular to x2, y2. So this way it will come back. So this is the projector of P and this is also the projector of P. So these two projectors are crossing at a point, and so here we will get point P1. So now here, see, one line is true length. Here A1, B1 is a true length. We have written it here. So that is why PQ will become perpendicular to AB, because we have seen out of two lines, if any one line shows true length, then we get 90-degree angle between lines. So that is why mark a perpendicular from point P on line AB. This is why. So here you will get point Q1. So why Q on AB? Because it is given in problem. Point Q is on line AB. So that is why we will get point Q1 here. Now take it back again in front view. So how to transfer it? Perpendicular to x1, y1. So locate it here on line AB. Now we need to transfer both P and Q in top view. So how to transfer these 2 points in top view? So perpendicular to our regular XY. This is point Q's projector. So Q is on line AB. So locate here Q. Now transfer projector P, projector of P. Now where to locate point P here in top view actually? So see, do we have any other top view? Yes, we have here auxiliary top view. So here in top view we have a point P. So this point P from auxiliary top view we will transfer here in this top view. So how to transfer? It is our regular XY and this is x1 y1. So measure the distance of point P from x1 y1 and locate from xy. So as we are coming reverse, so we will have minus 1. So x1 y1 minus 1, that is xy. So take this distance, measure it from x1 y1 and locate it from xy. So here you are getting point P. Join it. So this is how line PQ is completed in top view. This is the entire solution of the problem. Okay guys, try to solve it on paper. Use scale. Without scale don't try to solve the problems. Use scale and then try to solve it. If any difficulty comes, feel free to contact. Thank you.